This is section 8.2, and today we're going to talk about arithmetic sequences and partial sums. And we're going to finish this unit by doing geometric as well. So our first job is just to figure out what's arithmetic and what is geometric. So arithmetic is where the difference between any two terms is addition or subtraction. So if you're adding the same amount each time or subtracting the same amount each time, that is called an arithmetic sequence. The common difference is the amount that you're going up or down by. Whoops, that's not how you spell. Keeping in mind that the common difference could be negative if you're going down, if you're subtracting something each time, and it'll be positive if you're going up. So we have a couple of formulas here, and you can find these on, or you're going to add these to your formula card as well, or pick one up the first time you come back to class. But we have recursive formulas and we have explicit. Remember, recursive we use about 1% of the time. It's not a super helpful formula to have, as you have to keep writing terms to find the next terms. So if you want like the 10th term, you have to write 1 through 9 in order to get there. So recursive is not super helpful. But it starts off with the first term. You have to tell everybody where you're going to start. And then after that, you're saying, I'm going to use the previous term, and I'm just going to add the common difference to it. Probably should have wrote up here the common difference is often denoted as D. So take previous term, and you just add D to it. So if we're going up by 5, or like this one, we're going up by 4, my common difference would be 4. The explicit formula, those are nice. We use those 99% of the time because they can help us find any term whenever we want it. So if I want the 10th term, I just get to plug in a 10, and I've got the 10th term. So this formula starts out with first term plus, and then n minus 1, and n is just the term that you want. So if we want the 10th term again, we just plug a 10 in there, 10 minus 1. And then D is your common difference. So that's the explicit formula. We use that quite often when we're writing any kind of sigmas or we're trying to find terms in a sequence. So first one says, can you write an explicit and a recursive for each of the following sequences? So first I'm just going to figure out what this is going up by. It looks like we're going up by 4 each time. So I'm going to write my recursive, I'll write explicit first. Would go an, and first term is a 1 plus n minus 1, and then common difference is a 4, and that's it. You can distribute the 4. You could simplify. You can come up with 4n minus 3. That is also equivalent, but this is just fine. Just plug in all the numbers where they belong, and you're good to go. The recursive formula then, remember, it has to start with the first term. You have to tell me where to start. And then after that, you're going to take the previous term, so an minus 1, and you're just going to add the common difference, and this time it's a 4. And that is your recursive. It takes both of those parts to make the recursive formula. Next one is decreasing to go from 12 to 9.5 to 7 to 4.5. We're actually minusing 2.5 each time, or subtraction. So that is my common difference. So when I go to put it in formulas, I just got to make sure that it is negative. So my my explicit, we did that one first. First term is 12 plus n minus 1, and my common difference is negative 2.5. Again, you can distribute if you want, but that's totally fine. You can leave it just like that. The recursive formula, first term is 12, so we got to have that. And then after that, you're just saying, I'm going to take the previous term, and I'm going to add the common difference, which happens to be 2.5. So you can just subtract 2.5, or you could add negative 2.5, whichever way you'd like to write it. So a little practice on explicit and recursive formulas. Now we're going to try one where we get our information in just a little bit different way. So this one says the fourth term of an arithmetic sequence is 20, and the 13th term is 65. So I don't know the first or the second or the third, but I do know the fourth, and that is 20. And then down the list a ways, the 13th term is 65. They would like us to figure out these first several terms. And in order to do that, we have to know what the common difference is, or what they are increasing by. It is a great hint for us to know that this is arithmetic at this point. So we know that whatever they're going up by, they have to go up by the same amount. So I'm going to show you a couple of different ways you can do this. Some students notice right away that there is a pattern between the 4 and the 20 and the 13 and the 65, that if they multiply by 5, that they're getting their answer. So 5 is the common difference. So they just kind of did 4 times what's going to get me to 20, 13 times what's going to get me to 65. And that came out to be 5 both ways. So common difference is 5. Another way to do it is you could use your explicit formula from up above and say, well, 65 is kind of like my last term. First term I don't know yet. That is my 13th term, so I'll put that in there. And common difference we don't know yet either. So to adjust this a little bit, we're just going to pretend like this is my first term. It's the first thing that I know. So I'm going to use that as my first term. And then it will not be 13 terms away. It actually will be 10 terms away. And times our common difference, and now we can solve for our common difference. So the way that I figured out 10 actually is if you were to count from 4 all the way to 13, lots of students typically do subtraction right away, and 13 to 4 is only 9. When you learn subtraction, what it's really teaching you is the spaces in between. So think about like if this was 3 and this was 4, 5, 6. When we teach you 6 minus 3 for 3, we're counting the spaces in between. But when I want to know how many terms there are actually 4 terms here, 3, 4, 5, and 6. So subtraction just counts the space, and we kind of need like one more to account for this extra term that we're going to plug in. So you can do 13 minus 4 and get your 9, but then you need to add 1 so that you get that last term that you're going to plug in. So that's where I get the 10 from. If I were to solve this, I also get 5, so I know my common difference is 5. Yet another way to do this is I have some students who say, well, the difference between 65 and 20 is 45. And the difference between 13 and 4, again, they're just talking about space, the space between them, is 9. So if I divide those, that means every space between there has got to share 5. So I found that the common difference is 5 in a few different ways, a few different methods, and now I'm just going to work backwards. So if this is 20, this has got to be 15, 10, and 5. So there are my first few terms. What would happen if we wanted to add our terms together? And that kind of comes in handy because we are often doing sigma notation, which is a sum. So we need to talk about the sum of a finite arithmetic. So finite means that it's going to end, that it has an end, or that we're only going to add up so many terms. And the formula looks like this. N stands for the number of terms you want to add up. A1 is your first term, and AN is your last term. So if you wanted to add up the first 100, then this would be whatever your 100th term is. So we're going to try it just on a couple of examples here. Find each sum. So I'm going to set up for sum. I might have to take off my shoes and count the number of odd numbers there are from 1 to 19. So I go 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. There are actually 10 total odd numbers. First term is a 1. Last term they gave me, that was 19. So that's pretty slick. I'll just plug that in my calculator and I get 100. So if I were to grab a calculator and start adding up 1 plus 3 plus 5 plus 7, seems like it's really small, but once you start adding them to this other end, I actually end up with 100. Next one, we're doing another sum. From 1 to 100, that's pretty easy. It's 100 terms. First term is 1. Last term they gave me is 100. Plug all that in, I get 5,020. Pretty straightforward forward to use. Just make sure that you know how many terms there are. That's usually a tricky point for kids. And then if you need to know the last term, like we're going to do the next example, we're going to have to go find it. So this one is just a word problem. I've got a small business that sold $10,000 worth of sports memorabilia its first year of operation. So my first term is $10,000. The owner of the business has a goal to increase sales by $7,500 each year. That's D. I want to go up by $7,500 every year for the next 19 years. So assuming that they meet the goal, find this total sales during the first 20 years of business. So sum, I've got the number of terms, 20. I know my first term, 10,000. Plus, problem is I don't know my last term, how much money I'm going to make in that last year. So off to the side, I'm going to say, all right, I need to find my 20th term. And I'm going to use my explicit formula to do it. So first term is 10,000. Plus 20 minus 1, and my common difference is 7,500. So grab my calculator, I get 152.5. That's going right here. And then enter all that in my calculator, and I get $1,625,000 over the course of those first 20 years. Next up, we're going to do something called a partial sum. So if you have your formula card in front of you, the very last box on the top row, so arithmetic infinite, actually cannot be done. So you can put an NA right in that box. You cannot find the sum of an infinite arithmetic sequence. So this one's going up by 11, and not an H, 11. And no matter how high I get up there as we start to add these, I'm always adding another 11 and another 11, finding bigger and bigger numbers, which means this will never level off. Like I can't find the sum of all these terms because they're not leveling. They just keep going up. But I could cut this off. I could go out for 150 terms, cut it off, and say just add up those. So that's what we're going to do is a partial sum, since I can't do the whole thing, can't do an infinite when it is arithmetic. So 150 terms divided by 2. I know the first term's 5. I don't know the last term. So I'm going to come off to the side again, and I'm going to do my 150th term. First term is 5. 150 minus 1. The common difference we said was 11. So I'm going to get done solving this. I'm going to find out it's 1,644. I'm going to use that and just plug it into my formula. So if I could add up the first 150 terms of this sequence, I would get 123,675. So that's kind of your introduction to arithmetic. We've got a sum formula for finite, has to end. You cannot do it if it's infinite. And then we've got our recursive and explicit formulas.